Warning, if you have a short attention span or you're stupid, do not watch this video. This is for the nerds out there. I made a dumb video, so if you're dumb, watch that video. It's linked in the description. Hey guys, today I'm going to be teaching you how this massive thing over here works. It looks pretty complicated, but it's actually quite simple. So I'm just going to give you like a step-by-step guide how it works from the keyboard all the way to the screen. So you can see here there are note blocks with observers next to them, so each of the note blocks is equivalent to one of the keys. And when you tap on one of the note blocks, it gets encoded into a specific binary code. I can show you that happening if I just slash tick freeze. Let's say I tap this. Yeah, so you can see those specific torches go on because that's what they're encoded to. The binary encoding for this number would be 01001, 0, as you can see here. It travels all the way up here, and because there are multiple different rows, the different binary slots all get combined into one, so no matter where you press it from, it's always going to go into the same binary number. Anyway, you can see they went up to the top there, but I'll talk about that later. Anyway, here is where that binary number gets sent through, and then this, it looks quite complicated, but it's actually really simple. So the binary number goes into here, runs all the way along this middle line, and basically what each of these different things are is decodings for that character. So it decides which character it is, and then outputs all the pixels of that. So for a H, you can see the pixels are on, off, on, off, on, off, on, off, on. And basically that's what this ROM unit is telling you. That's all it's doing. And then these repeaters are to have a delay, because I'm actually not sending it across 15 wires, I'm just sending it across 5 wires in series, because otherwise this would be triple the size if I was sending it across 15 wires, and it'd be absolutely huge. So I just send it across 5 different wires, one for each row. You can see here, like, I think this, well, if I go right to the start, this is a 1. You can see that it's encoded to only 1 at the bottom and then nothing else. And if you look at all the pixels it's encoding to, you can see the number 1 written. So the top one, and then that one, the middle one, the middle bottom, and the bottom one. So if I was to, draw that out, it would look like this, which you can see is a 1. Another thing that this keyboard does is whenever any of the buttons are pressed, it will send a signal across this line, and what this does is it sends a message to this counter to move right a slot. The next time you press a button, the letter will go into the next slot afterwards, because if they were all going into the same slot, it wouldn't work. That's not a keyboard. Okay, so after you have the pixel representation of the letter in these 5 wires, it travels all the way along every single character position. It travels all along all of them. It goes up here to every single character position, but it only gets let through at one of the character positions. So you can see all these comparators are all locked. The only one that's unlocked is these ones, because that's where the next character is going to go, because you can see that the text cursor is there. Okay, let's say that this was unlocked. When the pixel representation of the letters comes through here, and it goes through this section, then basically what happens is it gets locked by these repeaters. The way it does this is with an SR latch that listen to the signal bit. I actually didn't talk about the signal bit. If you move all the way down here, you can see that at the start of every encoding that the ROM unit gives, there's a signal bit, and this tells the screen when to lock its repeaters. It's quite clever. So then when it locks its repeaters, all the information that's been running across gets locked in place. And if you wanted to clear that slot, then it'd be really easy, just unlock all the repeaters. And to do that, you reset the RS latch. So yeah, it's pretty simple. Then that just goes onto the display, so yeah, it just shows exactly what's on the repeater locks over there. Okay, so when I talked about most of the comparators being locked and stopping the pixel representations of the letters coming in, well, that is all decided by this circuit here. What this is basically just 2 counters, one for the X, that's the X, and one for the Y, so that's the Y. This counter is just made up of an adder that loops back round all the way back into the input, so you can add whatever number you want. You can add 1, you can add 2, you could take away 3. It's not restricted like a normal counter is, which I think is really cool. So whenever there's a backspace, for example, you can take away 1, and whenever there's a right arrow, you can plus 1. So then this binary number gets outputted here, and it's sort of a similar logic to a matrix decoder, because there's a row for which Y coordinate is decoded, and then there's columns for which X coordinate is decoded, and only when the X and the Y are both off can the comparators be uncancelled and the pixel representations can be let through. So that's why the whole screen just doesn't completely fill up when you press a letter. It only goes into one of the slots. It's also the exact same thing that decides where the characters get put into, is what also decides where this text cursor goes. It's literally based off the exact same circuit, it's feeding off it. There's no storage, it's just wired directly to there. And then you have this small bit of ROM, which I made signs what they do. So for example, if you press backspace, then this line turns off, and what it does is it turns this torch on, which you can see is decrease x, because when you backspace you want to decrease x coordinate. And what it also does is it sets this purple line is a reset line, so it resets the character position that it's on. And then all the other commands have different things that they do. For example, one of them is return to 00 coordinate. It just sets both of the things to 00. Yeah, and that's pretty much everything you need to understand about it. It looks pretty daunting when you first look at it, but once you understand it, it's really not that complicated at all. A lot of it's just copied and pasted across all the different character positions. So yeah, like and subscribe, check out my other videos on my channel, and yeah, peace out.